Hey everyone, my name is Venelin, and in this video we're going to have a look at how you can build powerful AI applications by enhancing large language models with essential capabilities. We're going to start by having a look at how you can add memories to your LLM applications. Then we're going to continue with getting structured output as a response from an LLM. And then we're going to continue with tool use and knowledge retrieval in particular. All of this will be done just using pure Python, Pydantic, and a vocal LLM using Ollama. Let's get started. Modern LLMs such as GPT 4.5 and Claude 3.7 are really powerful, but adding additional capabilities to those models make them incredible. In their blog post Building Effective Agents, the Anthropic team calls those types of LLMs enhanced LLMs. So this is the instance of those types of models within this diagram, which is very much inspired by their blog post. So in the center here, you have a large language model, and this is taking a prompt input, and then this LLM is providing you with some response. So in order to get better responses, depending on the task that you're going to do, this LLM has access to do two different concepts. The first one is memory, from which it can understand the previous history of the conversation with you or other users. And the other one, a more general one, is tool use. You can get a tool that is, for example, a knowledge retrieval for extracting information from an existing database, or even call a calculator in order to do some calculations for the model. And then based on the response of this tool and the memory of the previous conversations, you can get even better results compared to just using a plain old LLM. If you want to follow along, there is a complete text tutorial that is available for ML Expert Pro subscribers, and it is called Sharpen Your AI Toolkit, Memory, Structured Output, and Tools. Here you can find the complete text tutorial along with a link to the GitHub repository that we're going to use in order to show you the code, along with complete explanations for each part and access to the complete Get Things Done with AI bootcamp. So if you want to support my work and get access to the complete bootcamp, please consider subscribing to ML Expert Pro. Thank you. The first concept that we're going to take a look at is memory. Without memory, users would be forced to give the context for each conversation every time that they're asking something, and this wouldn't be very practical for real-world applications. On this example that I'm showing you right here, we're going to be using the simplest possible version of memory, and that is by passing a list of messages with custom special types. So in this case, I'm getting the Qwen 2.5 Ollama model that I'm going to run through this example. And in order to give it a chat request or a prompt, I'm going to be asking the chat function from the Ollama package. And here I'm also specifying the model, the temperature, 0, so we want to have as reproducible results as possible, and then the list of message objects. So in here, I'm essentially simulating a conversation that has already happened, similar to what you might have within a ChatGPT UI applications. And first, I'm giving it the content of this. What did the name of the Tor anonymity network originally stand for? And let's pretend that the model has already answered onion routing, and I'm saying think deeply and try again, reply only with the full name, and I'm passing this list of messages right here, and this is the response. So to run this, I'm going to be just executing the script, and you get the final response, which is the onion router, short for Tor. So in this example, we're using a simple memory, but in practical applications, you might want to have something like called windowed memory, when you are essentially taking a look at n last messages from the previous conversation. Then you can summarize some parts of the conversation as well. You can also create what's called structured memory when you're going to remember only certain things about the conversation. So for example, if a user is coming around and wants to be recommended a diet, for example, maybe he or she will tell her weight, probably her eating habits, etc. And these are things that you want to store for later, for future conversations. So in this case, you might have a database in which you're going to store particular information about this user. Next, let's talk about structured outputs. This is where the LLM is going to return an object of a certain type. In this case, we're going to be using Pydantic. And why you would want such a thing? Essentially, when the LLM is returning just plain texts, you wouldn't know if it made any errors, and you will need to parse the structure of the response, which sometimes can be error prone and hard to do as a developer. So in this case, you would essentially can provide a schema using a pedantic object in order to get the response that you want as a structured data class. So let me show you how you can do this in practice. First, you need to define your pedantic object by extending the base class from the library. And in this case, I'm going to have a quiz question. In this quiz question, I will have the question itself, which will be a string. Another cool thing about these structured outputs is that you can essentially provide types that you want as responses, even if you're using just Python, which is not a typed language, of course, or not type enforced language. Then we have the correct answer with, again, a single string field. Also note that within those fields, I'm also specifying the description of those fields. This will be added to the prompts for the LLM and will make parsing or getting responses that are within the correct format even better. So keep that in mind. And then I want a list of incorrect answers. So this will be the final field of our quiz question data class. So in order to run all of this, I'm going to be using again the same Qwen 2.5 model, and I will have this question, which is essentially a free text format that I'm going to be passing to the LLM, and the LLM is going to be converting this free text or plain text information to a structured output using Ollama. So the prompt is extract the question and answers from the text and format them as a JSON object. And then I'm passing in the text that is going to be passed in. Then I'm going to be creating the message. This time I'm just adding a single user message with the prompt and then formatting the question. What did the name of the Tor anonymity network originally stand for? The correct answer, the onion router, and a list of incorrect numbers as well. My favorite, of course, is garlic routing. So in order to make all of this work, I will just do an additional property call to the chat function from the Ollama package. And here I'm going to be using our quiz question model and then do this model dot underscore JSON schema. So let me show you actually what this is going to give you, since we are going to be giving this to the Ollama model. And then I'm going to continue with that. So when I execute the script, you see that we have the complete schema. So you have the name of the object, the type of the object, along with the question and its description, as you can see here. Then we have a title of question, type of string. Note that everything is here. Then we have the field for the correct answer, title correct answer, and then type of string. Then we have the incorrect answer, items, type string, and type of array. So all of these, along with the required parameters, are created for us thanks to the Pydantic library. And if I run through all of this and remove this print right here, after I get the response, I'm going to get something such as this. Again, let me show you, since we are in an interactive environment. So this will go and call the myWoko Ollama instance, and this will be the response. So it will be a JSON message with the question, the correct answer, and then the incorrect answers. So you can see the power of the structured output just by calling this property of the chat function. And if I finally do the model validate JSON from this same message right here and print essentially the question, you see that we get a quiz question along with the question, correct answer, and a list of incorrect answers from the structured output. Pretty powerful, right? While LLMs are great with just the concepts that I've shown you thus far, by far the most powerful addition to your LLM that you can do is enabling access to tools. So in this example, I'm going to show you how you can use an external API to essentially enrich the knowledge base of your LLM. And within that process, I'm going to show you how you can code the information that your LLM needs in order to do the call to the tool, and then how you can integrate the response of the tool within the LLM. Why tools are really important? For example, when you have a private database for your company or your own business, you can access private information from your database using tools and provide this information to your LLM, something that can enhance significantly the performance of the LLMs based on your data and your private information. Also, you can call external tools to do some form of operations that might be hard for LLMs. One particularly good example is actually calling calculators, and you can get a very good response from the tool, and you're certain of that. Here, we're going to be using the OpenTB or OpenTrivia database with their API, which is a free API. And here I'm adding first the fetch trivia questions function, which we're going to turn into a tool in a minute for the LLM. And the API is going to be called with amount, which is going to be the count of questions that we want to get as a response, the type, and then a category. So for that category, we have computers and vehicles as the only available categories. You can, of course, extend this further if you want to. And then I'm going to get the response from the API along with the parameters and convert the results into our own quiz question data type, that is the Pydantic data class, and then just return a list of questions. So let's run this function. I'm going to print the trivia questions, and I'm going to comment out this one. Let's save it and run the tools. So what you see here is that we get the API, and from that API call, we got these three different quiz questions. Note that this won't be deterministic. So if you call, or even if I call the API another time, I'll get a different set of questions. But all the time, you should be able to get questions that are quiz questions typed to our own Pydantic classes. So now that we know that how you can essentially code this, let's continue with the tool use and how you can integrate this information within our LLM. So first, I need to specify the parameters of the function for our LLM. And to do that, I'm going to create another Pydantic object, which is going to be creating the structure information about the parameters for our tool. And in this case, for our function, again, we have just the count and then the category. And the category, I here specified that we have just two different options, computers and vehicles. Let's see how I'm going to define this as the parameters. Pretty much in the same way, I'm going to specify the category type to be a literal. And in this case, it's going to be able to choose from computers and vehicles. Allowed values are computers and vehicles within the field. And then for the field of count is the number of quiz questions to fetch. Then I'm going to create these two spec, which is going to be a function or a JSON dictionary with a type of function. And then for the function, I'm going to specify the name of the function right here, fetch trivia questions. I'm going to give a good description and retrieve a list of quiz questions from the Open Trivia Database API based on the provide count and category. And then I'm going to use the model JSON schema to create the parameters of these two. And now let's actually go and print this to have a look at what we are getting as an output for the complete tool that we have. So you can notice that pretty much everything up to here is provided by us manually, but using the Pydantic library, we are actually providing the properties, the count, along with the description. And then for the category, you see that we have a type of enum with computers and vehicles, which are the only available options that the LLM should choose from. And then here at the end, we are also specifying that both of those are actually required fields or parameters for the LLM. So this looks pretty cool. And let's see how you can integrate this with the LLM. So let me go through the flow right here. First thing that you need to do is to create a dictionary of available tools for the LLM call. And in this case, I'm going to be having just a single possible tool that the LLM should call, and this will be the fetch trivia questions tool. And then for the messages, I'm going to be specifying a prompt that is provided by the input of this function. And then for the chat, this is where we are going to provide the specification for the tool. The tool spec is going to be added as a list, and this list is going to contain just our tool spec. And here we'll specify the description of the possible tools that the LLM have. And when I execute this, you see that we are going to get a message. And let me actually just end up this here and run the code up to here so you can see what is happening actually. And run this. So this is the response from the first call to get me 3 quiz questions about computers, format the output as Markdown. So you see here that we don't have a content or a message, but we have something new, which is this list of tool calls. And since we're only using a single tool, the LLM, which is in this case Qwen 2.5, and note that not every LLM is capable of doing this, unfortunately, but Qwen is quite good at it. So Qwen said that we are going to be calling the function called fetch trivia questions, which is the function that we passed in, with the arguments of category for computers, since this should be inferred from here, and then count equal to 3. So based on this prompt, it figured out the possible or the correct arguments, and then the name of the function that we're going to be calling. So thus far, this looks pretty good. Let's continue with this code right here. So in order to do the tool call itself, what we are going to do is to get the tool from here, and then from the tool function dot name, we're going to get the function name, which is going to be the fetch trivia questions. And then from the available tool dictionary that we have, we're going to get this particular function or tool that we have created. So this now is a pointer to the fetch trivia question functions. And then with the function arguments, which is function arguments right here, we are going to be casting this into a dictionary as an input for our function, for the parameters. And then this will actually call the fetch trivia questions with category of computers and count equal to 3. And then the response is going to be this tool result. Note that nowhere in here we have an LLM that is doing here. This is just executing the function in our own code. And if I run this, you see that we got a lot more information this time. First, we got the tool call, which is the first thing that we saw. And then after the execution of the tool, which is the fetch trivia questions, we got these 3 different questions based on the category for computers and a count of 3. So it appears that everything works pretty good thus far. And then what we're going to do is to add the response that we got from this message. And this can be actually done way up here, just to not confuse you. The interesting thing that we're doing here is that we're actually adding a new row for the tool call with the content of the output of the tool, and then the name, which is the fetch trivia questions. So this will be added to the messages and returned as a response. And I'm going to show you here the list of the messages that we're going to get as a history that we're going to be passing to the next LLM call. And let's see what we got as the list of messages. And this will be the actual history of the conversation that we're going to get. So the first one is going to be our first question. Get me 3 quiz questions about computers, etc. Then we're going to be adding the tool call to the history, and then as a row of 2 with the fetch trivia questions, we're going to be getting this giant string from our API call, and this will be added to the next call that I'm going to show you how we are going to do. But this will be the history for the next call. This is very, very important. Let me remove this and call our final function, which is going to be the display final response. So in this function, we are just going to give the history thus far to the model. And then I'm going to be printing the response into a nice markdown if the model is actually formatting the response into a markdown. Let's run this. So this is the first call to the LLM. And this is the response that we got. Here are 3 quiz questions about computers, Dutch computer scientist, etc., with the possible questions and then an answer to that. Again, the possible answers and the correct answer, etc. So we got the complete output formatted as a markdown thanks to the Qwen LLM, and we did all of this using a tool call. One of the main weak points of modern LLMs is that they have this thing called knowledge cutoff, and even models such as GPT 4.5 have a knowledge cutoff of year 2023. Now we are in 2025, and you can imagine that this model doesn't know a lot about the past year or so, which might be a big problem about the overall responses that you're going to get from these models. One way to solve this is to use Retrieval in order to add additional information from external sources to your LLM prompts. And in particular, you can also use this same technique to use on your private databases, private files, PDFs, etc., in order to augment the knowledge of your LLMs. In this example, I have a knowledge base that is composed of 5 different questions and their answers from the Quiz Trivia API. And these are the questions in a JSON file. So what we're going to do here is another way to do tool calling with the retrieval part. And again, I'm going to be using the same model. And I have a tool specification of search questions, find the question in the database based on the provided question text. And here I specified manually the parameters so you can see how you can do this as well. And I can just provide to this function the question itself, which is going to be a string, the question text to search for. So here is the tool that we're going to be using, and you can see that it was the questions database converted into a list of dictionary objects. And then for each item from the question, I'm converting the input question query as a lowercase string, and then I'm finding this within the question title from the database that we have. And if I have a match, essentially, I'm returning the quiz question along with the complete information about it. Otherwise, I'm returning unknown. And here you can see that I have an optional return value. So I'm going to specify that this can be a non-response. And then I'm going to be cooking or running this with a retrieve answer with tools. But first, let me show you how you can call this by providing this part right here. So what is the main name of the country Tuvalu? And this is the direct search result. I'm just giving the perfectly matching question right here. And you can see that this is returning, the tool that we're using is returning a quiz question with what is the domain name for the country Tuvalu, with the correct answer.tv, with the incorrect answers as well. So in the next one, I'm going to be adding a query to our LLM. What is the domain name of the country Tuvalu? Find the answer from the database. And I'm going to be calling our function retrieve answer with tools. And here you can see that I have pretty much the same setup that I had before with the search questions, then with the prompt. I'm passing in the tool specification, and when the model is giving me this tool selection and response, which is going to be the search questions, I'm going to be appending this message to the history. I am also checking that I have just a single call, and I'm calling the search questions function with the argument for the question provided by the LLM. And then these will be the messages that I'm going to append the response to. And I'm going to be again calling the LLM with the history, just as we did in the previous example. And finally, I'm returning the response right here. So let me show you the actual tool call, because this might be a bit interesting for you to see what actually the LLM thought that it's going to be all right for us to call here. Let's return this and rerun this. So based on the question that I've passed in, it said that question is what is the name for the country Tuvalu. And you can see that it essentially removed this part right here. And after you do this, we are going to continue with the original flow. Let me remove this and now call the model itself. The main name for the country Tuvalu is .tv. This is the response of the LLM combined with the tool call execution for knowledge retrieval. As you can see, we have integrated this knowledge within the prompt of the LLM, and we got an answer that is grounded within the knowledge that we have and we want to use for our application. This is essentially the main part of building a retrieval augmented generation applications, or RAGs. So in this case, we are going to be using something very, very simple, which is a JSON search essentially. But in the real world, you will probably use something such as hybrid search, semantic search, keyword search, or other sources of information in order to provide data or text to your LLMs and get even better results compared to just plain LLMs. So this is it for this video. We've seen 4 powerful techniques to enhance your LLMs. We've seen how you can use memory to keep contextual information about the conversations with your LLMs. Then we've seen how you can get structured output of your LLMs in order to get responses that you can use right within your applications. Then we've continued with the probably most powerful enhancement, that is tool use. You can essentially give enhanced capabilities to your LLMs, and these can be pretty much unlimited. And then we have provided a way to integrate external information or knowledge base right within your LLMs using Retrieval. If you want to have a complete access to the source code that I've shown you and the text tutorial along the way, please subscribe to ML Expert Pro. I'm going to link the tutorial down into the description of this video. In the next one, I'm going to show you how you can build a complete chatbot that uses some of the advanced techniques for the memory applications, and I'm going to show you how you can build all of that using Streamlit, Pydantic, and LangChain. Thank you for watching, guys. Please like, share, and subscribe. Also, join the Discord channel that I'm going to link down into the description of this video. And I'm going to see you in the next one. Bye.